Hey there, Stover here, and what we're going to do is I'm going to work through a couple questions, and then I'm going to stop and let you work through a couple questions. The first one I get is pretty easy. I'm just pulling out molar ratios. And remember, molar ratios are based on coefficients. Okay? So what that means is that we're looking at these numbers in front of each atom or molecule. And then we're just writing a coefficient that looks like this. So for example, O2 as compared to CO2 is going to be 13 to 8. See, 13 O2, 8 CO2. All we're doing is pulling out these molar ratios. So O2 as compared to H2O, we have H2O here, we have O2. We've already discussed that O2 was 13, so that's going to be 13 to 10. Then we have C4H10 over here, which is going to be 2. We're just pulling out these molar ratios, these coefficients, and then compare that to CO2. On the product side, it's going to be 2 to 8. And you could actually simplify that if you wanted to, but we're not going to. So C4H10, again, C4H10 as compared to E as compared to H2O is going to be 2 to 10. And again, you would be able to simplify if this 13 wasn't here. So, and you could simplify even between these specifically, but then that would make your equation unbalanced. So those are the molar ratios, and these are very simple for us. We got that. So let's do this. Given the following equation, 2 potassium chlorate yields 2 potassium chlorides and 3 oxygen molecules. So our question is, if 12.0 moles of KClO3 react, how many moles of O2 are produced? So this is going to be our substance A, like we talked about the other day, because we are given this. And this is going to be our substance B. How many moles of O2? This is what we want. And so we just set the stoichiometry problem up with this. If we are given mass, we convert to moles. Okay, and since we already have moles, we don't have to do this step. So now, if we have moles A, we convert to moles B. This is super easy, and we do that through the coefficients. Okay, so let's do this. So we got 12. We're going to write this down. 12.00 moles of KClO3. And we are going to now at that point set our T-chart up with our coefficients, right? Because we already have the moles right here. Now we're just going to pull our coefficients. KClO3, whatever's on top, must go on the bottom. So that's going to be 2 KClO3 moles. Okay, and so we can cancel out our moles here. And so we can cancel out KClO3. Now what we're going to do is take our coefficient of substance B that we're trying to get to, which is this, B, and put that up here. And so now what you do is 12, 24, 36, you multiply across the top. That's going to be 36, and you're going to divide that by 2. So that's going to go 1, and I'm doing this without a calculator right now. So 16, so it's going to be 18 moles O2 produced. 18 moles O2 produced. So let's just walk back through what I just did there. I'll erase everything besides my answers. Okay? Erase everything beside my answers. And let's go back through that. So we were given 12 moles. So that's going to be substance A, given. Okay? We were asked how many moles O2. So B is going to be wanted, and that's going to be O2. Given is going to be KClO3, and that's going to be 12 moles. Okay? And so we are trying to get here. Now remember our steps. If we are given mass, we convert to moles, and we do that through the molar ratio off the periodic table by or molar mass off the periodic table by adding all of that up. If we're going from moles A to moles B, we just simply use our coefficients. So that's what we did. We used our coefficients, and then that was all it wanted was moles B. How many moles? So let's set it up again. So it'll be set up like this. You got 12.00 moles KClO3. Boom, T-chart. Now, we already have moles. We have KClO3. Now what we're going to do is set up our mole A to mole B. So I'm going to put mole A to mole B up here. Now we do that through the coefficients. Whatever you have on the top, you have to have on the bottom. So we got moles KClO3, and we pull our moles from here, 2 moles, and then we want to go to oxygen, O2, how many moles of oxygen. So we pull our coefficient, we put that there, 2 moles O2, 3 moles O2. And so all we do is multiply across the top and then divide by the bottom. Multiply across the top, divide by the bottom. And that's going to give us 18 moles of O2 that are produced. So we just went from moles to moles. Now, let me do another one. If 4 moles, here we go, 4 moles, there's going to be our given right off the bat. I don't even have to think about it. If 4 moles react, how many moles of KCl are produced? So now we have our substance A, and then we have our substance B, and we're going to follow the same process. We've already got moles, so this is what we're going to do. We're going to go moles A to moles B, and we're going to use our coefficient. We don't have to worry about mass. So now we're just going to write down our 4 moles. 4 moles of KClO3, and whatever you have on the top, you have to have on the bottom. So we're going to put our T-chart there. We're going to look back at our coefficients. Let me erase those so we can see our coefficients clearly. We're going to look back at our coefficients, and we have KClO3 on the bottom, so we look at this. So we're going to put a 2 mole KClO3, and what we're going to put on the top, what we are going to, is what we're going to put on the top. And it's saying how many KCl. Here's our coefficient. We put that on the top because that's where we're headed. 2 moles KCl. Now all we do is multiply across the top, and we divide by the bottom. So this is going to be a pretty easy one. 4 times 2 is going to give us 8, and then divided by 2 is going to give us 4, so that we see we're going to get 4 moles of KCl produced. 4 moles of KCl produced. So that was mole to mole conversion. Mole to mole conversion, one of the easiest ones out. But let me write the steps down for mole to mole conversion again. If you didn't get that, you can rewind that because I want you to fill out this whole sheet. So the steps are going to be from mole to mole, right? They're going to be moles of substance A, which is given, and then you are going to convert to substance B, moles B, wanted, and the process you're going to use is going to be moles A, T-chart, coefficient A, coefficient B, and that's going to be what you're being asked for, and that is going to give you your answer. You multiply across the top and you divide by the bottom. So those are that, and so go ahead and do let's see how many moles produce. Go ahead and do 3 and 4, and we'll come back and we'll work through those. Hold on, good, okay, cool. So let's see, you should have done 3 and 4. Okay, So we are still looking to go from moles to moles. So moles A, substance A, to moles substance B. In order to go from moles to moles, we are going to use our coefficients. Simple coefficients. And we see our coefficients as the numbers in front of the atoms or molecules. So what you should have done is you should have noticed that your given is going to be substance A, which is moles K, moles potassium. So you should have just went ahead and wrote that down, 2.50 to 0.5, make that point, 2.5 moles potassium. And then you drew your T-chart, I'm sure. And if you're going from moles to moles, you don't have to go from, you don't have to think about mass. You just use your coefficients. So at that point, what you're going to do is you are going to use your coefficients. Whatever you have on the top needs to go on the bottom. So we have moles potassium on the top. We need moles potassium on the bottom. Moles potassium on the bottom. Where do we get our moles potassium to put here? We just pull them down from the coefficients. It's going to be 2. And then we are going for substance B, which is KCl. We go 2 KCl. We just pull 2 moles KCl. And now we're ready to multiply across the top and divide by the bottom. So let's do it. Just a calculator. You probably can do this in your head, but I'm not going to. 2.50 times 2 divided by 2 is going to give us 2.5 moles KCl. Now that should have been your answer. Remember, if you're going from moles A, you write moles A on the top. That's going to be what you're given. If you're going from moles to moles, then you do your coefficient A and then coefficient B, and that's going to give you your answer. Your coefficients again are right here. So let's do another one. Let me get this out of the way. Let me change colors real quick. Actually, I'm going to change colors this whole time just to kind of walk through this whole process. So how many moles, here's going to be our substance B, right? How many moles substance B are produced from, here's our substance A. Substance A is right there. So we see that. Now let's do a quick check on our equation to see if it's balanced. We got Na2, we got 2 Na. We got O2, we got 2 oxygen, we've got H2, and we got 2 hydrogen. So we're good to go. Now we're going to take our substance A and just write it down, because here's what we do. Moles A. So moles A is going to be 1.20 moles of, what is our A? Na2O. Na2O. We don't have to do any molar mass calculations here because we already have moles. Now whatever you have on the top, which is moles, and Na2O, has to go on the bottom. So you can just go ahead and write that down. Na2O, moles. And how many moles do we have based on the coefficients? Na2O is going to be 1, so we're going to put a 1 there. This is going to be super easy. And then we see our substance B, what we're going to, is NaOH, and so we have 2, boom, right there. So now 2 moles NaOH. You're about to hear my kids yell. But now we just multiply across the top and divide by the bottom. Multiply and divide. So let's do it. So we got 1.20 times 2 divided by 1, and that's going to give us 2.4 moles of NaOH. NaOH. Okay? So what you should have done again, and I'm going to erase this up here and just write it down again for us. That way we get it. Okay? If we are going to do a mole to mole conversion, we are going to set it up like this. Our moles A is what we're given. We're going to put that in the top left of the T-chart. we're going to come over here and we're going to go straight to our coefficient section to go from moles A to moles B. Moles B. And to do this step right here, we're going to use our coefficients. Simple, and our coefficients are in our balanced equation. We always want to check to see if the equation is balanced. Okay, just give it a quick check, because if you get the wrong coefficients, you are going to be wrong. But most of the time, I'm just going to give you balanced coefficients. All right, so let's move on to the second part, and I'm going to work those for you, and then you're going to work the next few, okay? All right, so on these problems on the next worksheet, they're going to be a little bit more difficult because they're kind of mixed up. So what I want to do is I want to go ahead and give you the equations to use. So if you just jot these down or take a screenshot of these, you will be completely fine as far as steps are concerned. So let's do this. If you are going from, let's say, mass A to mass B, and again, A is what you have in the equation. They'll always give you the number, what you have, and then B is going to be what you want to find. So if you're going from mass A to mass B, then what you're going to start with is like this. You're going to do your T-chart. You're going to write down what you have, which is going to be mass A. And then you are going to write your T-chart out. Now, the second step is that you are going to put your molar mass that you discover from the periodic table, molar mass of, and from now on, molar mass is going to be MM, and coefficients is going to be CE after this one. So molar mass of A, and that's going to be equivalent to 1 mole. And it's always going to look like that. Okay, if you're going from mass to moles, it's always going to look from mass, mole up here. Now, once you have moles A, then you are going to go to moles B. But since you have moles A on the top, you have to have moles A on the bottom. And this is where you use your coefficient for A. And this is where you put your coefficient for B. Right there. So again, you are going from molar mass to moles of A. Now you are going from substance A to substance B through the coefficients. And now you're, if you're going to try to find your mass, now you're going to use your 1 mole of B is always going to be equivalent to the molar mass of B. And that's going to give you your answer, okay? That's going to give you your answer. So that is mass to mass. Again, if you just take this down, right here, then you will be able to see that's exactly what you want to do. If they ask you, you have one mass and they want another mass, you'll be able to do exactly these steps. Now let's go from mass to moles. So mass to moles, mole, and it's going to be mass to mole B. Mass A to mole B. So then what you have is you put your mass A up at the top that you've been given. You put your molar mass, because you need mass and mass, molar mass A, top and bottom. Now you do, that's going to always equal 1 mole of A, right? And now we just do our coefficients. So we're going to put our coefficients, I told you it was going to be CE and MM, and I just forgot. So CE, coefficient A, because we have A, and this is moles, and this is moles, coefficient, and then you put coefficient B at the top, and that will give you your answer for B, moles B. Okay? So now let's go from moles to moles. Moles A to moles B. Remember, A is what you have, B is what you want. So say you're given moles A, you put your moles A on top, do your T-chart. Since we don't have to do this mass step right here, Then all we do is jump to this step and put our coefficients in. So this is going to be coefficient A, and you are going to go to coefficient B, okay? And that's going to give you your answer for B moles, okay? That's moles to moles. That is super, super easy. Mass to mass is the longest one. And then, say, for example, if we're going to go from moles A to mass B, it's going to be a little longer, but we'll be able to figure it out. So notice this. We are given moles A, so we put our moles A on top. Moles A, that's what we're given in the equation. We know that if we start with moles, we don't have to do that first mass step, so we just jump straight to our coefficient. So we're going to put coefficient A, because A is on the top, moles are on the top, so coefficient is always going to stand for moles. And then you do coefficient B, because that's where we're headed, mass, but we're still not done because these are still moles, coefficient B. Now you drop down. If you got B on the top and moles on the top, you need 1 mole of B is going to be equal to the molar mass of B, and that's going to give you your answer for B mass. Okay, so these are the general equations. If you write them down, memorize them, it's pretty simple. You always go, if you got mass and you're going to mass, you always go mass to moles, and then moles A to moles B, and then moles B to mass B. All right, so those are your directions. Now we're going to jump back into the actual worksheet and get some of these done. All right, welcome back. And like I said, this part of the worksheet is going to give us a little bit more difficulty, but it's still very doable. So we are going to need a periodic table and a calculator for this. So let's go. Ready? So we are going to do a quick check right off the bat to see if our equation is balanced. So let's look at it. So we have 8 iron, we have 8 sulfur, we have 8 iron, and we have 8 sulfur. So our equation is balanced. We don't have to balance anything. We're good to go. And I'll generally give you balanced equations. Okay, so we see right off the bat that we have substance A. Oh, and it gives you a hint right here, by the way. So we have substance A, that's what we've been given. 4.2 moles of sulfur, which is this, sulfur, react with, it reacts with this iron. So what is the mass of FeS produced? So remember our process, we already have moles and we have our substance A, so we're just going to write it down. 4.2 moles of sulfur, okay? So that is what we do. We skip that first mass step and we go straight to the coefficients. So we have sulfur on the top, moles on the top, so we need sulfur and moles on the bottom. So we're going to look up here, and we have no coefficient in front of sulfur, so that's just a 1. So we're going to put a 1 there. 1 mole sulfur, because that's our coefficient. Now, we are looking to produce FeS, so that's going to be 8. 8 right there. We're still not done because it asks us for the mass, but this is going to be 8 moles of substance B, what we're looking for, FeS. So now we know we're going to have moles on the top and moles on the bottom of FeS. So we are going to say 1 mole, because this is where we use our molar mass. 1 mole of FeS is going to have a molar mass of, let's look, Fe is going to be right here, and we're going to round that. So that's going to be 56. 56. And we only have 1 Fe, so that's 56. And then we have sulfur, FeS. That's going to be plus 32. 56 plus 32. That's going to give us 88. 88 grams per mole, because that's our units. So that is our molar mass. 80, I think I said 86. Let's see, what did I say? 88 grams per mole of FeS. Now we're set to do our calculations. So let's go across the top. You ready? So it's going to be, let's see, 4.2 times, because we multiply across the top, 8 divided by 1, because we divide by the bottom, times 88, because we multiply across the top, divided by 1. And you don't have to do the one step, because unless you want to, I do, just to make sure I'm getting it right. But that's going to give us 2,956 grams of FeS. That's a lot of grams produced. It's a lot of grams produced. But we have this 8 moles here, so that makes a lot of sense. Okay? And if you wanted to, you could have rounded that to 29567. 29567. So that is the first one that we will do. Now you go ahead and you try B. Pause the video, seriously pause the video and try it. All right, so hopefully you tried it. That's up to you. I'll never make you be as brilliant as you can be. But here we go. So we still have the same equation, the same general thing. So we're going to erase it so that we can see our coefficients clearly. It's still balanced. So now we have 13 moles of Fe reacting. So that's going to be our substance A. Okay, now we're again going to the mass, so we're going to still need our molar mass, but we already did that. FeS is going to give us this 88 grams. We already did it by looking at the periodic table and adding it all up. So let's go ahead and do this. So we're going to write down our substance A, 13 moles of Fe. We're going to put that down. Boom. We have moles on the top, Fe on the top, so we need moles Fe on the bottom. And then what are we going to use for the moles? We're going to use our coefficients. Fe is going to have an 8 right there. Now we have been asked to find FeS, so we're going to use that coefficient. That's going to be 8 as well. 8 moles. We have now got to substance B, but it's asking us for the mass of substance B, so FeS. Okay, so now what we do is we find our mass of FeS, but since we have moles on the top and moles and FeS, we have to have moles FeS on the bottom, and 1 mole, based on molar mass, is going to be 88 grams per mole of FeS. So let's get that done. Ready? So we just do our multiplication across the top. So that's 13 times 8. Then we multiply, or we divide by the bottom, divided by 8. And then we multiply across the top times 88. And then we divide by the bottom, divided by 1. And that's going to give us 1,144 mass grams per mole of FeS. Okay, so that was B. So take a second, pause the video, come back, you try question 6. All right, here we are, question 6. Let's go back through it. Question 6 is going to look like this. We're going to do a quick check to see if our equation is balanced. So we have 2 Na, we have 2 Na, we have 2 Cl, we have 2 Cl, we have 6 oxygen, and we have 6 oxygen. So our equation is balanced. We don't have to worry about that. So now let's just jump right into the stoic. Ready? The stoic is, here's our substance A, because it's what we've been given, and it's NaClO3, which is sodium chlorate, and that is going to ask us how many grams of O2. This is going to be our substance B. Substance A is right here. Substance B is right here. This is what we want. and this is what we have. So if we know that, we already start with moles, so we don't have to do that first mass step, so that's going to be easy. So we just write down 5.50 moles of NaClO3. Boom. Draw our T-chart. Now, since we're already at moles, we just jump straight to the coefficient section. And since we have moles and NaClO3 on the top, we need that on the bottom. So we have a 2 moles NaClO3, and we are being asked to go to oxygen, substance B. So now we look at our mole ratio here and our coefficient. So that's going to be 3 moles O2. So now we are at substance B, okay, but it's still asking us grams, so that means how much mass. So now we're going to have to figure out the molar mass, and we're going to have to figure out the molar mass of O2, okay? So the molar mass of O2. So the mass of oxygen, number 1, is going to be 15. We're going to take that to 16. So that's going to be 16 times 2. That's going to be 30, let's see, 612. 16 times 2, 612, 32. 32, let's go back. So that's going to be, here's our moles. We have moles on the top, so we need moles on the bottom. Moles, and how do we know how many moles go on the bottom? That's because we are saying 1 mole is always going to be equivalent to the molar mass, which is 32 grams per mole of O2. Now we just simply do the math. We multiply across the top, 5.50 times 3, because we multiply across the top, boom, right here. Now that's going to be divided by 2 because we divide by the bottom, right? Now we are going to times that, multiply that by 32, divided by 1, and that's going to give us 264 grams produced of O2. That's our answer. So that's pretty simple, right? Let's do another one. Pause the video and check out B. So B says this: how many? What does how many mean? How many means substance B? We don't know. What does given mean, or what is A? It's what we've been given, and that's a number, so we see it. So we see 60 grams of NaClO, and remember, our equation is balanced, so we're good. That decomposes, that just means it reacts, it means it goes away. Okay, so don't worry about these words like that. But this is a how many grams are produced when grams are decomposed. So this is going to be a fairly long issue. So let's go ahead and get this done. So we're going to go from mass to mass, right? Mass B, mass A to mass B. So let's go. So here we go. So we have 160 grams of NaClO3, okay? And so we write that down. Now, if we start with grams, we always use our molar mass to get to moles. So if we got grams on the top, we need grams on the bottom, okay? If we've got NaClO3 on the top, we need NaClO3 on the bottom. So here is where we are going to find our molar mass. So let's go to our periodic table, and we have Na, 1 Na, so that's going to be 23 because we rounded, Na, and then Cl right here, 35, so Na plus 35, NaCl plus, and then we have 3 oxygen, so it's going to be 16 times 3, and that's going to equal 106 grams per mole. So now we have 106 grams per mole right here, and that's going to give us 1 mole because that's how much 1 mole has in grams in it, okay? So now we have 1 mole in NaClO3. That's where we convert from substance A to substance B, and to do that we use our coefficients. So now we are going to take our molar ratio. NaClO3 as 2, so it's 2 mole NaClO3 because we have that on the top, moles and NaClO3. And we are being asked to go to NaCl. So we have 2 right here, 2 NaCl, 2 mole NaCl. And now we can't stop there. We are at substance B right here, but it's asking us how many grams, how much mass. Okay, so now we have to go back and we have to do our, we have moles on the top and NaCl. So we're going to put 1 mole NaCl. And how much is the molar mass for 1 mole of NaCl? Well, let's go back just to see it. Na, just 1 Na is going to be 23 plus just 1 chlorine, so that's going to be 23 plus 35. That's going to be 58. So we're going to go back and we're going to say 58 grams per mole NaCl. Okay, so now we're going to do all of our math. This is going to be where we need to be very careful as far as getting the right numbers in. So it's going to be 160 times 1 because we multiply across the top. Now we're going to divide by the bottom. We're going to divide that by 106. Okay, now we're going to multiply that by 2 times 2. But then we're going to divide it by 2, divided by 2. And then we're going to multiply again by 58. And we're going to divide that by 1. And that's going to give us, the number on the calculator is going to be 87.54. But we are going to round that. And we are going to say that 88 grams of NaCl are produced. This is our answer. Okay? So that was your kind of walkthrough for today's worksheet, moving through stoichiometry. What I want you to do for homework is simply, this is your only homework. What I want you to do for homework is number 7. Okay, both of them, number 7. And you can go back, check out any of these videos that you want, and just make sure that you have that. If you have any questions, you can email me, you can hit me up via whatever. So, yeah, anyway, hopefully that helps. Finish up number 7.